Hello, welcome to another RPD video. Today we'll be talking about surveying. Before we get into what a surveyor is, we need to understand those three main concepts. Retentive undercuts are areas underneath the height contour of the tooth where retentive clasps engage. That helps the RPD stay in, aka retention. Guide planes are flat areas on the surface of the abutment teeth that is next to the edentulous space. Along with the guide plate that is on the partial, they provide guidance to the insertion and removal of the partial denture. Rest seats are areas prepared on the surface of the teeth that accommodate an occlusal rest that is present on the partial denture framework. Now, before designing an RPD or preparing guide planes and rest seats, you'll be asking yourself, how do I determine the path of draw? What angle should my guide planes be? Where should my clasps go? And where should my rests be? Now, to help you answer all these, we have what we call a surveyor. This here is called a Ney surveyor, and you can use that instrument to help you determine the path of insertion of an RPD and determine the location and depth of the undercuts. It comes with a bunch of tools. They're usually hidden in that screw right up here. You've got a wax trimmer, an analyzing rod, and 3 undercut gauges. We also have a carbon marker along with a lead shield. So, the first thing we're going to do is we're going to place that analyzing rod into the mandrel, which is this part right here. We're going to place our cast onto the table, this instrument right there. That table allows you to move your cast in all directions around all axes thanks to this universal ball joint right here. The mandrel represents the path of draw of the RPD. So, in whichever angle you set your table relative to the mandrel, that would be the angle that your partial will eventually take to be inserted and removed from the patient's mouth. And since our guide planes determine the path of draw, the mandrel angle compared to your table also determines the angle that your burr would be taking when preparing guide planes. So, whichever angle you have your table set at relative to the mandrel is the angle that you'll be taking in the mouth while preparing your guide planes. So if you have your table set at an angle relative to your mandrel, that will be the exact angle that you would need to take in the patient's mouth. Obviously, you will not be tilting your patient, rather you will be tilting your handpiece, unlike the surveyor angle relative to a table. Once you've identified an appropriate path of draw, you can move forward with tooth preparation. The guide planes are prepared to coincide with your planned path of draw that you did on the surveyor, and eventually, your RPDs would also follow the same path of draw. You can now appreciate that tooth preparation for the guide planes is dependent upon the planned path of draw that you've decided on the surveyor. And this is especially important when you're surveying cases with tipped teeth such as this one. In this particular case, you've got a premolar and a molar that are tipped opposite each other. When planning your guide planes, if you plan guide planes that are following the contours of the premolar, thus requiring minimal reduction of the premolar, you'll end up preparing so much of that molar, and that wouldn't be right. Similarly, if you go the other direction and make a planned path of draw that coincides with the molar, but in return you prepare a lot of the premolar, that wouldn't be correct either. The best way to approach this is to divide tooth preparation between both teeth, thus avoiding excessive damage of a single tooth. So, we're done with determining the path of draw. Now let's move on to determining the retentive undercut location and depth of the undercut. For this, we'll go ahead and use the lead marker and the metal shield. We'll place those on the mandrel, and we'll go ahead and go through the process of what we call drawing the survey line. To do that, we're going to go ahead and use both our hands to move the table across that platform, and at the same time we're going to be moving that mandrel up and down to coincide with the tooth contours. One hand will be controlling the mandrel, and the other hand will be moving the table. When you move them together, you'd be able to move the mandrel up and down the contours of the tooth as you move the table to move the cast across the mandrel. As you do this, the side of the lead marker will rub against the height contour, thereby drawing a line that we call the survey line. Underneath the survey line are undercuts. But how deep are the undercuts, you ask? For that, we'll have to use undercut gauges. Typically, 0.02 and 0.01 undercut gauges are used. Let's assume that this is a cast, and this is a tooth that you've surveyed on that cast. This black line represents your survey line, thus this is the height contour. To measure how much undercut you've got here, you're going to go ahead and pick one of the two undercut gauges, and take that undercut gauge and place it so that the shank and the disc are both contacting the surface of that cast. Usually, the shank will touch at the height contour, which is also the survey line. Wherever the disc touches, considered a 0.02 undercut. You'll usually use a pencil to mark that area. You can see if we use a 0.01 undercut gauge, again, moving it so that the shank and the disc touch. That disc will now be considered touching at a 0.01 undercut. In this slide here, you can appreciate the difference in distance representing the 0.03, 0.02, and 0.01 undercuts. So why do we need to draw the survey line? And why do we need to know where the undercuts are? Different clasps require different undercut depths. Additionally, reciprocal elements like the reciprocal clasp need to be above the survey line. For those two reasons, we will need to know where undercuts are located and how deep they are. And of course, we have classification systems in place for our survey lines. A Class 1 survey line is a survey line where it is very low, close to the edentulous space, and higher away from the edentulous space. Same is true for both sides. A Class 2 is just the opposite, a survey line where it's highest, closest to the edentulous space, and lowest, further away from it. A Class 3 is a survey line that is even on both sides of the tooth, close and away from the edentulous space. A nice way to memorize this is to use the one away, run away, to indicate that the undercuts are away from the edentulous space, and two towards, meaning the undercuts are close to the edentulous space. Rick and Morty always helped you. Tripoding is the last step you do after surveying, and it acts as a safe point, or in other words, a way to return your cast to the specific tilt you had it in when you were surveying after you've changed the position of the table. For this, we will be using the 0.03 undercut gauge. You'll put that on the mandrel. Once you're ready to tripod, you're going to set the mandrel at a fixed height, meaning you are not going to be moving that mandrel up and down anymore. The instrument you're using, the 0.03 undercut gauge, needs to be able to contact the cast when you bring the cast closer. Now, we're going to go ahead and put the cast under the mandrel, and we're going to move it in 3 different directions. First, let's move it to the right. When we do that, that 0.03 undercut gauge is going to contact the point on the cast. You're going to draw a little red line and a blue circle around that location. Some people also scribe a little indent in the cast. Then you're going to move it to the other direction and repeat the process forward. Now we've got 3 different locations which you can come back to again and effectively save your position. Is that a bit confusing? You're not alone. Most people think it is. And that's why currently there are software like 3Shape that allow you to do this in a more immersive way. I'll leave a link down in the description for a study that is free to access that explains how to do this using 3Shape. You can also check out our video here that shows our newly developed software that allows you to design and survey casts using our newly developed software. Thank you for joining us, and I hope you understand surveying a little bit better. Join us next time for our next RPD video.